Well, are you ready for spherical coordinates?
Yes!
Good. So when a point in space is notated in this system, okay, it'll be rho, theta, phi. Rho is the distance from the origin to the point. So right here is the rho. As in row, row, row your boat, right? But that's how you say it, but it's R-H-O, the Greek letter for small r. So that's the rho. Theta is the same thing as it is in cylindrical coordinates. It's the angle between the positive x-axis and the point's projection into the xy plane, or into the r theta plane, if you will. Same thing. And then the angle phi. Now phi, this is a different thing. Phi is the angle between the positive z-axis and the ray from the origin to the point. So phi is this angle in here. So this picture really tells you a lot of everything. You know, here's the point given as x, y, z. Here's the point given as r theta z. See, r is this value, theta is this value, and z, of course, is this value. And here's the same point given as rho, theta, phi. Rho, theta, phi. Notice this theta is red because it's the same theta as this one. And the green stuff just pertains to spherical only. If it's red, then it's cylindrical. But in cylindrical and in spherical, the theta means the same thing. Be warned, different books, different subject areas. For instance, I think most physics books have this the other way. They will have rho, phi, theta, where phi is the angle from the positive z-axis, and theta is the angle from the positive x-axis to the point's projection into the xy plane. So you get a new book, you get a new subject area, look up and see for sure how the cylindrical coordinates are defined, because they might be different. So notes the rho is generally positive, but it could be negative. But in our text there are only positive values of rho. In other words, you could pick all this up and make a negative value of rho. I guess that would probably stick it down here or something like that. No, if rho is negative, it would be down here, right? If this angle was negative, now wait, this one's always going to be between 0 and pi, or if you're a degree fan, 0 and 180. This one will always be between 0 and 360. So, okay, the theta has a representative in 0 to pi, of course, but there are an infinite number of such possibilities. And the phi is generally in the interval from 0 to pi. If it is pi, then it's on the south pole. If it's pi over 2, if the angle phi is pi over 2, then where does that tell you the point lives? Look at the picture. If the angle phi is pi over 2, then the point must be in the fill in the blank. It must be in the xy plane.
Well, yes.
Of course.